Hello, ladies and gents. Welcome back to Strange Headlines here with Dennis Saliba, Occult and Fortean. And in today's video, I'm going to be covering two articles, more on the technical side today, more on the science and technology side, but nonetheless, still strange phenomenon and wild times in a rather strange and wild 2025. So today's article is going to be about scientists grow mini human brains to power computers, written by the BBC. So this is an article released on the 4th of October 2025 by Zoe Kleinman. And as the title suggests, we are going deeper into the trans-humanist agenda and where science fiction seems to meet reality. So let's get into it. So it may have its roots in science fiction, but a number of researchers are making real progress trying to create computers out of living cells. Welcome to the weird world of biocomputing. Among these leading the way are a group of scientists in Switzerland who I went to meet. One day, they hope we could see data centers full of living servers which replicate aspects of how artificial intelligence learns and could use a fraction of the energy of current methods. So just a little comment on this. Current AI tech is very electricity intensive, and it seems that current levels of AI technology do not have the energy grid to power it the way that we would want it to en masse. And also cooling is a major issue with current silicon motherboard type of technology, and a lot of water is needed from a technical perspective to cool down these systems. So these living servers or living computers have their own benefits, it seems. So that's probably why they're trying to dabble into living computers. This is the vision of Dr. Fred Jordan, co-founder of Final Spark Lab. I've got to research them a little bit more. I've visited. We're all used to ideas of hardware and software in the computers we currently use. The somewhat eyebrow-raising term Dr. Jordan and others in the field use to refer to what they are creating is wetware. In simple terms, it involves creating neurons which are developed into clusters called organoids, which in turn can be attached to electrodes, at which point the process of trying to use them mini computers can begin. Sorry, guys, my guess is that these mini computers then, or these brain computers, basically run like human biological computers in the sense that they run on electromagnetic impulses, and then the electromagnetic impulses send data through the neurons, just like a regular human brain. By the people, for the people. Oh, it's been a long time. How are you doing? One of my all-time American viewers. How are you doing? It's been so long. Yes. Oh, good evening here. It's evening time here, but good morning in the US. You probably don't remember me, but I've been your American viewer. Yeah, I do remember you, actually. You're one of my OG supporters when I used to create journalism content, but now I don't create journalism content anymore. I create occult content. On occasion, I do cover articles. I want to get into more weekly streaming again. It's been a while. I think so many things have happened in the last year and a half. That's why I've taken a big hiatus of YouTube, but I'm back. I've rebranded. I've got new things going on. And I'm away from all of the politics of all of those other former groups. I won't name them. Both sides, I might add. That's both sides. How skin cells are turned into mini brains. So human skin cells are turned into stem cells. Okay. The stem cells are cultured to become clusters of neurons. No surprise. Eventually becoming little spheres, collectively called organoids. After several months, the organoids are attached to an electrode. You know what this might sound like? This is speculation. This is not a conclusion. This might sound like the proof of concept or proof of viability concept study for Neuralink. They're trying to see if they can build up the interface between biomechanics with silicon and traditional electronics. Sourced by Final Spark. Yeah, it's kind of interesting to see how crazy this stuff is going to go. But not, again, to no surprise, because we're talking about quantum computing, and that a quantum computing brain is obviously going to need neurons, which can, to an extent, self-cool themselves compared to silicon chips. And then that there's way less of a need for silicon to be produced en masse from a technical perspective, and you can much more cheaply and much more effectively grow organoids in place of silicon chips. Obviously, there will be a motherboard, and the motherboard will send data out in the 3D realm as part of like a qubit. That's how a quantum computer works. But those neurons could receive qubits compared to a traditional silicon chip, in the sense that they could receive it in 3D real time without the need for a broadband signal. So that seems to be where we're heading. I guess we'll see what further signal technology brings. Dr. Jordan acknowledges for many people the very concept of biocomputing is probably a bit weird. It is weird. And it also goes against the natural law. And again, if anything in the occult scene or in the occult sense of this show will tell you that you're going to hear that phrase a lot. It is against natural law. Set my own way. Hey, man, how you doing? Good to see you on board, man. They're not even miniature brains. They're actually average-sized American brains. Roasting an entire population of people within the first line of my live stream. Goddamn, that's pretty funny. Damn, no pulling punches there. When you start to say I'm going to use a neuron-like little machine, it's different. It's a different view of our brain. It makes you question what we are. It makes me question what the hell the scientist wants. What's his name again? Dr. Fred Jordan. What's your end game, Dr. Fred Jordan? Huh? When you start to say I'm going to use, I've already read that, for Final Spark, the process begins with stem cells derived from human skin cells, which they buy from a clinic in Japan. The actual donors are anonymous. That's so strange. Do the people even have the right to consent to this? Or are they just donating their stem cells for research, and then that research is not disclosed? What world are we living in? But perhaps, surprisingly, they're not short of offers. We have many people who approach us, he said, but we only select stem cells coming from official suppliers. Okay. So they are commercially registered. These are commercially registered supply chain organoids, which are trackable and traceable through transactions. Okay, because the quality of cells are essential, or QA. I don't think it's just QA. That's the ethical concern there. Maybe I'm being a bit too skeptical. But I think it's the reason why they keep it in the business, this is from an accounting perspective, is because they can monitor the transactions and audit the transactions far more effectively than if you were to do it out of house. Still pushing to create Frankenstein? Yeah, it seems so. All scientists are government endorsed. Yes, it seems so. It definitely seems so. In the lab, Final Spark, cellular biologist Dr. Flora Bruzzi handed me a dish containing several white orbs. Man, reading these articles does make me uncomfortable. But again, this is kind of world that we're in. So like, I can imagine this being used to power the brains of the female sex robots with artificial wombs in them that we covered yesterday in the previous article, in the previous stream. I could imagine this being used as part of that interface now that I think about it. Each little sphere is essentially a tiny lab-grown mini brain made out of living stem cells, which have been cultured to create clusters of neurons and supporting cells. These are organoids. They are nowhere near the complexity of a human brain yet, but they have the same building blocks. After undergoing a process which can last several months, the organoids are ready to be attached to an electrode and then prompted to simple keyboard commands. This means for electrical signals to be sent and received. I'm guessing these electrical signals being sent and received are through analog computers or digital, but not quantum computers. We're talking the current crop of computers. The results recorded on a normal computer hooked up to the system. It's a simple test. You press a key which sends an electrical signal through the electrodes, and if it works, it doesn't always. You can see just a little jump of activity on a screen in response. What's on display is a moving graph, which looks a bit like an EEG. You press a few times in quick succession, and the responses suddenly stop. There's a short, distinct burst of energy on the chat. When I asked what happened, Dr. Jordan said there was a lot. They still don't understand about what the organoids can do and why. Perhaps I annoyed them. Well, because you keep pushing the envelope of technology, it raises questions about agency. And again, this goes back to autonomy and the nature of rights. Are these things classified as a category of like a third form of life, a third party, a third form of life, a cyborg? Probably a cyborg is what comes to mind, or an android, probably an android. And then do they have human rights? By creating post-humanism, do they even have human rights? And then do they have agency, or are they on command through remote? I have so many questions about this. This is crazy. Electrical simulations are important first steps towards the team's bigger goal of triggering learning in the biocomputer's neurons so they can eventually adapt to perform tasks. Probably not autonomous tasks. The complexity is not there for that yet. For AI, it's always the same thing. And again, by AI, probably an LLM, not AGI. That's different. We're not at AGI levels yet. You give some input, you want some output that's used, for example, so it sounds like an LLM-based model. For instance, you give a specific picture of a cat, and you want the output to say, if it's a cat, he explained. Keeping biocomputers alive. Keeping an ordinary computer going is straightforward. It just needs a power supply and cooling. But what happens because of laws of thermodynamics? But what happens with biocomputers? It's a question scientists don't have an answer for yet. Of course they don't, because there's no SOPs for this. Of course they don't. Organoids don't have blood vessels, which is true, said Simon Schultz, professor of neurotechnology at the director for neurotechnology at Imperial College London. The human brain has blood vessels that permeate through multiple scales and provide nutrients to keep it working well. Yet we don't know how to make them properly. So this is the biggest ongoing challenge. One thing is for sure, though, when we talk about a computer dying with wetware, that is literally the case. Oh, so if these cells die, they flood and they secrete water. Interesting. Final Spark has made progress in the last 4 years. Organoids can now survive for up to 4 months. Ah, man. So these brains, this is back to the article about the artificially grown lambs. There was an artificially grown lambs article back in like 2016, 2017 that I covered in a previous show of mine. These brains have outlasted those lambs, because those lambs were terminated. Remember, they were terminated up to 8 weeks to 12 weeks. But these are 4 months. So these brains are actually more viable than those lambs were, because they were terminated under HIPAA codes and under medical ethical codes of practice in the US system. You can't keep a cloned animal longer than 2 to 3 months, if I remember correctly. Not legally yet, anyway, in the United States, but there are some eerie findings associated with their eventual demise. Sometimes they observe a flurry of human activity from the organoids before they die, similar to the increased heart rate and brain activity, which has been observed in some humans' end of life. There have been a few events. We had a very fast increase in activity in the last minutes or 10 seconds of life. Jordan said, I think we have recorded about 1,000 to 2,000 of these individual deaths across the 5 years. What kind of supply chain do they have to have 1,000 to 2,000 of these recorded synthetic brain deaths? That's quite a supply chain. It's sad because we have to stop the experiment, understand the reason why it died, and then we do it again. Professor Schultz agrees that with an unsentimental approach, we shouldn't be scared of them. They're just computers made out of a different substrate of a different material, he said. Real-world applications. Funnel Spark are not the only scientists working on the biocomputing space. Australian firm, oh my gosh. First time hearing about these guys. Cortical Labs announced in 2022 that it had managed to get artificial neurons to play the early computer game Pong. Wow. Don't you have to be like 3 to 4 years old to begin being able to play Pong, so that there's an operative intelligence near to that of a raven in question? I have questions about that. In the US, researchers at Johns Hopkins University are also building mini brains to study how they process information, but in the context of drug development for neurological conditions like Alzheimer's and autism. This makes sense. Ethically, this does make sense because you're not having to rely on donor brains and you're not having to rely on live subjects. In terms of this application, I understand and I agree on my show. Let me know what you think in the chat, though. It's okay to disagree with me. That's perfectly fine. That application sounds reasonably ethical by the sounds of the way that they've framed it. The hope is that AI will be able to supercharge this kind of work. But for now, Dr. Lena Smirnova, who leads the research, of course, is Johns Hopkins University. This is also the same university that created self-replicating synthetic cell organisms, actually. It's another article I could talk about. Believes wetware is scientifically exciting but early stage. She said that there's little prospect of it taking the place of the main material currently used for computer chips. Biocomputing should complement, not replace silicon. I don't see how they're not going to work together myself, because something has to send out the signals. Biocomputing would be more efficient at receiving and coordinating the signals, but ultimately silicon AI is going to have to send out the signals while also advancing disease modeling and reducing animal use. Again, like it's an ethical application there. I get why they're trying to do it now. It's still strange, still irks me a little bit. Professor Schultz agrees. I think they won't be able to out-compete silicon in many things, but we'll find a niche. Even as the tech comes ever closer to real-world applications, however, Dr. Jordan is still captivated by its sci-fi origins. I've always been a fan of science fiction. Of course you are. When you have a movie of science fiction or a book, I always felt a bit sad because life was not like in the book. Now I feel like I'm in the book, writing the book. This guy is writing his own egregore. It's almost like this is a self-fulfilling egregore. Actually, rather than going to the other article to do with Switzerland, I had that posted originally, but I think this explains the overall concept. I'll skip over key parts of the article for the Switzerland article. I just want to go to the computer programming graphic. So this is the Neuro platform that they've experimented in within Switzerland. written on the 28th of May 2024 by Anaya Peleja. 16 lab-grown brains run world's first sleeping computer in Switzerland. That's the photo of it there. So it's essentially a motherboard, and then you see obviously there's these miniature brains forming the biomass, forming organoids, what looks like organoids are connected to electrodes. But I just want to go over to here. So from the looks of things, this is an LLM-based model again. There's a Python notebook connected to a database. The database sends and receives in-tan software programs and signals. There's a silicon trigger generator connected to a Wi-Fi. Is that a Wi-Fi? It looks like a Wi-Fi router. An in-tan controller, a bit like a Wi-Fi controller. And then head stage MEA is the mother brain connected to the incubated cells. That's one complex. With the input database Python notebook is the input-output database. Input Python notebook is the signals interpreting and signaling and command language. And then the in-time controllers, the input-output mode, so same as the trigger generator, and it's connected to this complex here. So basically, bioprocessors are a thing. It's in a proof of concept stage. Strange times that we're in. Hey, very strange, kind of odd. Biocomputers are real. What are your thoughts? Please let me know what your thoughts are in the comment section or in the chat. That's it for my stream today. I've got to go to work tomorrow, but I'll be back for more live streams on Strange Headlines. Strange Headlines seems to be the main hit of the show. Fewer people watch the edited videos that I create. I'm still going to create them. I still want to create Lao and Hungarian history, mythology, folklore, occult videos, videos about demons, videos about exorcisms, videos about superstitions. I have a video in mind about the nature of ghosts, what ghosts could be made out of. So I'm still in the process of editing that. And psychology stuff too. A little bit of psychology does tie into the occult and the Fortean, because it's ultimately about unmasking what's masked. I know the word occult gets a bad rap because a lot of Abrahamic religions forbid it. I get why. It's just part of the modus operandi. But at its core definition, Latin is occultare, which is hidden, basically. And you can look that up on Mark Passio's lectures on the occult. His older lectures, by the way. That's it, everyone. So have a good day, or have a good morning, have a good day, have a good evening, wherever you are in the world. Humanis Invictus. The human spirit is not conquered. It is unconquerable. The human spirit shall prevail always, forever. Bye for now, everyone, and take care.